Today we are taking a tour of Little Uvas Creek Preserve, located in the southern Santa Cruz Mountains. This preserve is managed by Santa Clara Valley Open Space Authority. It consists primarily of serpentine soils and grasslands, gray pine, and oak woodland. We are visiting Little Uvas Creek in the spring when blue, purple, yellow, orange, and white wildflowers abound. Shade is offered by a variety of oak and gray pine trees. Dragonflies and butterflies hover over, and ducks swim in the water of 5 perennial ponds. Birds fly in and out of the trees and bushes, and insects troll the ground looking for food. By the park entrance, there is a dilapidated 100-square-foot caretaker's hut from the early 20th century. Outside the small hut, there is lots of wood piled all over the place and a metal bedstead. The outer walls of the hut are covered with hexagonal tar paper, which at the time was an inexpensive but effective membrane to protect the wood from water. Looking inside the small space, there is space for a bed, and in the back, space for cooking. And there would have been limited plumbing and other amenities. Usually we see historical structures that are grand and architecturally significant, and we don't have any idea of how average or poor people lived. This would have been a good example of how poor people lived in the early 20th century if it had been stabilized and preserved for its historical significance. Senator Gibson of Solano County designated serpentinite, or serpentine, the state rock back in 1965 through Senate Bill 265. Serpentine is a spotted, mottled, dull olive green metamorphic rock, and its surfaces often have a shiny or wax-like appearance and a slightly soapy and slippery feel. The rock's name originates from the similarity of its texture to snake skin. California has the majority of North America's serpentinite. Specifically, it is located in the Coast Ranges, the Klamath Mountains, and in the Sierra Nevada foothills. Back in 1965, it was responsible for the state's newest and fastest industry, minerals, which brought tens of millions of dollars in revenue each year. This is because within serpentine rock is chrysotile asbestos, and asbestos was used for its insulating and fire-resistant properties. The reason I mention serpentine rock is because Little Uvas Creek Preserve is rich in serpentine rock, and over time the rock eroded into soil that is typically reddish, brown, or gray in color due to its high iron and low organic content. This soil is rare. It is most abundant in California, and even here it represents only 1% of the state's land area. Most of it is right here in Santa Clara Valley. In more recent years, the majority of our serpentine soil has been covered by human development such as houses, roads, and businesses. The single largest untouched block of soil, measuring 30 square miles, can be found in Coyote Valley, just east of Highway 101. Most plants cannot grow in serpentine soil because it is low in calcium and plant nutrients like nitrogen, potassium, and phosphorus, and high in magnesium, cobalt, nickel, iron, chromium, and other heavy metals. However, specific, diverse, and unusual flora have become adapted to and thrive in this soil. They have high concentrations of metals like nickel in their leaves, exhibit stunted growth, and typically have dull, waxy, gray-green leaves that allow for water retention and sunlight reflection to reduce water loss. Examples of common serpentine-tolerant shrubs and trees are manzanita, live oak, California redbud, lilac, buckeye, bay laurel, and gray pine. We see gray pine cones littering the serpentine rock area. Areas of serpentine soil are also home to diverse plants, and in California, a majority of them are rare or endangered. One such rare plant that is adapted to grow in serpentine soil is Dudleya. This succulent is less than 1 foot tall, originates from Baja California, and loves full exposure to the sun. There are 26 different species of Dudleya that are native to California, and 10 of them are classified as threatened or endangered under the Federal or California Endangered Species Act. The one we see here is growing between serpentine rocks covered with orange and yellow lichen. This species is called the Santa Clara Valley Dudleya, or Dudleya seychellii, and has reddish to pale pink stems and a handful of buds at the top of each stem. It has fleshy pinkish red leaves and sepals, and from May to June it blooms pale yellow flowers with bright yellow stamens peeking out from the inside. In 1995, it was listed as federally endangered. A large population was destroyed by the housing development on Communications Hill. A more recent example of destruction of this endangered plant was when Coyote Creek Golf Course used goats for weed control. These goats grazed between serpentine boulders where Dudleya was found. Now, it is found only in rocky outcrops of the Coyote Valley area of southern Santa Clara County. Interestingly, state and federal wildlife agents identified a surge in Dudleya poaching along California coastlines. Poachers were caught stealing thousands of plants, shipping them internationally, and selling them as trendy houseplants for top dollar. In California, investigators estimate that poachers have stolen several hundreds of thousands of Dudleya worth tens of millions of dollars. Assembly Bill 223 makes Dudleya poaching illegal. There are hundreds of native wildflowers that are adapted to grow in serpentine soils. We find soft blowwives among these serpentine rocks. They are from the sunflower family. They have spherical clusters of flowers that sit atop a strong, straight, 1 foot tall stem. This flower is fully fruiting, and each seed is attached to 5 narrow, alternating longer and shorter, silvery white, petal-like structures. The structures create a propeller-like parachute that easily catches the wind to help disperse the seed. Walking further on the serpentinite-covered hill, we spot bright blue, purple, yellow, white, and pink flowers. The blue flowers are bluedicks, and they sprout from a bulb-like structure called a corm that allows it to go dormant during periods of environmental stress, such as drought or fire. Corms are rich in carbohydrates, are food for a variety of animals, and were eaten raw or cooked by Native Americans. Bluedicks have a tall flower stalk with 2 or 3 grass-like leaves. The flower stalk reaches up to 2 feet tall, with a tight cluster of blue-violet flowers at the end of the stalk. These flowers also come in a white color. We find another wildflower adapted to grow in serpentine soil. Its purple flowers occur at intervals along the upper stem. The name of this plant is the most beautiful jewel flower, and it is the close relative of the federally endangered Metcalf Canyon jewel flower. The only way to distinguish between these two species is by the color of their sepals. Metcalf Canyon jewel flower sepals are white, and the most beautiful jewel flower sepals that we see here are purple. This annual herb comes from the mustard family and grows to 3 feet tall. It has bristly hairs at the base of the plant and has a pale green and waxy stem and leaves. It blooms from April to September. The flower has 4 long, frilly, and white-edged petals that peek out of the purple sepals. There are more than 40 different species of jewel flowers. While its cousin is federally endangered, most beautiful jewel flower is considered fairly threatened in California due to its loss of serpentine habitat, overgrazing, competition from weeds like star thistle, feral pigs, fires, and more. There are patches of gold fields growing among the serpentinite. They are a source of nectar for the federally threatened bay checkerspot butterfly. Native people collected goldfield seeds for pinole, or flour, and its seeds are eaten by harvester ants. This plant depends on moths, bees, and other insect pollinators. When they bloom, their quarter-sized flowers display 5 to 8 bright yellow petals and a slightly darker yellow center that contains clusters of flowers. Their stems and leaves are hairy. They grow up to 6 inches tall, and we see hundreds of them swaying in the wind. Serpentine morning glories are growing sparsely among the grasses and rocks. These white flowers are a rare species of morning glory because they are endemic or limited to the serpentine soils of Northern California. They have furry, pale green leaves with 7 to 9 lobes and curly edges. The white flower petals are fused, and the inside of the flower is pale yellow with 5 white stamens. Its seeds are stimulated to germinate by exposure to fire, so it is well adapted for the increased wildfires we have in the Bay Area. The biggest reason for it being placed on the endangered species list is because road construction, trash dumping, off-road vehicle use, and herbicides has destroyed much of its habitat. We see a large patch of serpentine lanathus, a small flower that blooms from March to June. Its flowers have 5 pink-purple petals and 5 bright yellow stamens at the end of a tube-like stem that has needle-like leaves. As its name suggests, serpentine lanathus will only grow on serpentine soil, so it's an endemic threatened species of the San Francisco Bay Area. There are a handful of gray pine cones laying on the grass. These come from the 3-needled gray pine, also known as foothill pine, that is native to the slopes of the Santa Cruz Mountains and is well suited to grow in poor soils like serpentine soil. The massive 6 to 12-inch long cones can weigh up to 2.2 pounds and fall directly from 80-foot tall trees. Each section or scale of the cone has heavy recurved spines intended to prevent animals from extracting the 1-inch seeds, but the cones can be dismantled scale by birds and rodents. The seeds play an important role in the diet of scrub jays, acorn woodpeckers, and California gray squirrels. Gray pine seeds were also eaten by Native Americans. The soonest a gray pine will start producing seeds is at 10 years of age. Mature gray pines are flammable. Their 10 inches long gray-green needles contain ether extracts, and its trunk produces a lot of resin. To balance this weakness, gray pine has adapted by self-pruning as the tree grows, which means they lose their lower branches so they are more likely to survive ground fires. Secondly, heat scarification of the woody seed coat increases germination rates. We walk a little further, past some blue oak trees, and arrive at our first pond. As I mentioned, the preserve has 5 perennial ponds, or ponds that are always filled with fresh water. Butterflies, damselflies, ducks, fish, frogs, birds, and mammals depend on these ponds for survival. As expected, we see numerous dragonflies and damselflies hovering over the water at the edge of the pond and by the tule, a native grass that has thick, rounded green stems growing up to 10 feet tall. Tule play an important ecological role at shorelines. They help buffer against the forces of wind and water, which reduces erosion. Do you know what the difference is between a dragonfly and a damselfly? One easy way to tell the difference is by focusing on their wings. When resting on a leaf or stem, dragonflies tend to spread their wings out horizontally. Also, if you can get a close enough look, their forewings are thinner than their hind wings. They also have thicker and shorter bodies. In contrast, when damselflies rest, they hold their wings together, vertically above their back. Their wings are all the same shape and size. Damselflies are more delicate and have long, slender bodies. If you can get close enough to look into their eyes, there is one more difference. Dragonfly eyes take up most of their head and are close together. In comparison, damselfly eyes are widely separated. One last interesting point. About 325 million years ago, there were 2-foot-long, magnificent, dragonfly-like insects flying around our planet. At the pond, we spot a bright red, almost 2-inch-long dragonfly that landed on a flower. Its huge eyes are darker red and look fused. Its sturdy abdomen is bright red except for 2 white spots, and its face is an orange-red. Its delicate wings are spread out and forward and are mainly transparent with red veins and a red perimeter. These cardinal meadowhawk dragonflies are in the skimmer family and have been known to fly long distances and over oceans. They eat soft-bodied flying insects such as mosquitoes, flies, termites, and small moths. Looking into a thicket of tule, we find 2 Pacific fork-tailed damselflies resting on a tule stem. They have a sky blue face, a mesothorax with sky blue sides and a black top, clear wings that are folded close to its body, and a long abdomen consisting of 6 black segments and ending in 2 sky blue segments. Its eyes are half black and half grass green and are clearly separated. Adult Pacific forktails eat a wide variety of small-bodied flying insects similar to the diet of the cardinal meadowhawk. They migrate from March to December. Nearby there is a patch of floating light green algae laying on the surface of the pond water. I see a Ramber's fork-tailed damselfly with a bright green thorax, black abdominal segments, and a light blue terminal segment. This damselfly is in the same genus as the Pacific forktail. It has to watch out for birds, frogs, spiders, and dragonflies who are looking for their next meal. Damselflies spend most of their life underwater as eggs, larvae, and nymphs. The process of reaching adulthood takes about 1 year. Once on land, most live between a couple of weeks to a few months, during which they need to breed. Specifically, Ramber's fork-tailed damselflies only live 4 to 10 days. We head to the corner of the second pond. Carefully looking into the water, we see a few 2-inch-long silvery gray fish with rounded tails swimming around the mud, rocks, and plants growing at the bottom of the pond. This is the non-native western mosquito fish, a native of central United States, which has been introduced all over the world and in California back in 1922 to control mosquito population and the diseases they harbor. Their mouth is pointed upward so it can feed on mosquito and other insect larvae and small flies that lay on the water's surface. They are opportunistic feeders capable of eating from the surface, bottom, or off aquatic vegetation, which means they have access to fish and amphibian eggs and zooplankton. Despite their size, they have a voracious appetite which leads to significant impacts on pond ecology. For instance, their aggressive fish and amphibian egg and insect larvae consumption has led to the disappearance of certain fish, frog, and damselfly species, and overconsumption of zooplankton feeders has resulted in algae blooms that reduce water quality. They are cannibals, so young fish must be careful not to fall prey to hungry adult fish. On the rocky bottom of a sheltered end of the pond, we see half-inch long, dark brown western toad tadpoles that have tails with rounded tips. Tadpoles feed on algae and take about 2 months to grow 1 inch in length before undergoing metamorphosis. In early spring, California toads mate and lay more than 16,000 eggs in ponds, lakes, and other still waters. Eggs are contained in a string of continuous jelly that protects them from mold and contains chemoattractants that guide the sperm to the eggs. The California toad is a medium-sized toad with many rusty-colored warts covering its back. The toad can be greenish, tan, reddish-brown, dusky gray or yellow, but most are brownish-gray. Adults have a white stripe down the middle of their back. They track prey by following their odor. They like to eat bees, beetles, ants, and spiders, but will also eat crayfish and grasshoppers. Like many other toads, the California toad uses poisonous secretions from parotoid glands and warts to deter predators. The ponds are habitat for a variety of birds that are singing in the tule, the surrounding bushes and trees, and as they swim in the pond. At the other end of the third pond, we hear quacking along with songs of red-winged blackbirds and see American coots, ruddy ducks, and mallard ducks in the water. We spot a male ruddy duck swimming, shaking his tail back and forth, bobbing his head up and down, and hitting his chest with his beak. These ducks are relatively small, with scoop-shaped bills and stiff tails that are cocked upward when swimming. Mature male ducks have a black cap that contrasts with its bright white cheeks. They have a rich chestnut-colored body and bright blue bills. He lifts his upper body out of the water and flaps his wings to propel himself across the water, and then lands again in one big splash. Ruddy ducks are strong swimmers and divers. They eat aquatic insects, crustaceans, zooplankton, and other invertebrates, along with small amounts of aquatic plants and seeds, but their favorite food is midge larvae. They forage by diving to the bottom of shallow ponds, straining mouthfuls of mud through thin plates on their bills, and swallowing the prey items that are left behind. They nest a few inches above water in cattails, bulrushes, or grasses. Male ruddy ducks perform unusual courtship displays in which they stick their tails straight up while striking their bills against their inflated necks, creating bubbles in the water as air is forced from their feathers. They punctuate the end of the display with a belch-like call. Courting males also lower their tails and run across the water, making popping sounds with their feet. About 10 feet from the male, we spot a female ruddy duck and her chick. Females and immature males lack the white cheek and the colorful bright blue bill and chestnut-colored body. While they do have a dark brown cap, the rest of their body is light brown. The male swims back toward his family and signals them to follow him. Ruddy ducks lay the largest of all duck eggs. Ducklings are quite large and fully developed when they hatch. They leave the nest one day after hatching and are able to swim and dive well. Ducklings become independent from their mother 3 to 4 weeks after hatching, but begin to fly at about 2 months of age. They are ready to breed for the first time at 1 year of age. By far the predominant bird songs we hear are from the bicolored red-winged blackbird. We see many birds repeatedly land on the swaying tule stalks and then fly off to forage. These birds like to congregate in flocks, with winter flocks containing several hundred birds. Red-winged blackbirds are a medium-sized, broad-shouldered perching bird. They have a slender conical bill and medium-length tail. Mature males are all black except for a large red shoulder patch. They belt out their song all day long to get attention. They fiercely defend their territories during the breeding season, chasing other males out of the territory, attacking nest predators like raccoons, skunks, snakes, and sometimes going after much larger animals such as horses and people. There is a female walking across tule stalks. Females are streaked and dark brownish overall, paler on the breast, and have a white eyebrow. Females tend to perch lower on the tule stalks to protect themselves and their nest. They nest in the dense stands of tule surrounding the ponds. Their nests are about 5 inches in diameter and made of long leaves and stems woven tightly around the tule stalks and lined with dry grasses, broken plant material, and/or mud. We see a red-winged blackbird picking at the ground for insects, spiders, and seeds. At the edge of the 4th pond on the grass, there is a killdeer running ahead a few steps, stopping to look around, and running on again in search of insects, spiders, worms, and seeds. Killdeer are the largest of the ringed plovers and have a characteristic round head, large eyes, and short bill. They are light brown on top and white below. Its neck is white except for 2 black bands around it. Its brown face is marked with black and white patches. When in flight, its bright orange rump and white wing stripes are clearly visible. Their nests are often found on open ground such as lawns, bare soil, or gravel, and not far from shallow water, which provides a good feeding area for the chicks. However, they are easily found by predators, so it is hard work to defend their nest. One trick they use is to make several nests not far away from each other, of which they only use one to confuse predators. On the ground among small and medium-sized rocks, we see chert, a shiny red rock. Abundant iron oxides in the chert produce its red color. Chert is a sedimentary rock rich in silica. Franciscan chert is formed when silica shells from marine plankton called radiolaria get stuck inside the layers of chert over evolutionary time. Radiolaria have existed since the beginning of the Paleozoic era, which was 600 million years ago, and their exoskeletons form a diversity of intricate and beautiful silicon shapes. Radiolaria range in size from hundredths to tenths of a millimeter. Their silica shells remain in the chert and can be extracted by crushing the rock into small pieces and soaking it in a solution of hydrofluoric acid. This is the same acid used to etch glass. The acid dissolves away the less durable rock matrix, leaving the exquisite three-dimensional shells exposed. The resulting microscopic shells are photographed using a scanning electron microscope. Some examples are shown here. Before we reach the end of our walk, we climb up a hill to get a view of Uvas Reservoir. This is an artificial lake that can hold almost 10,000 acre-feet of water. The lake was created in 1957 by the construction of the Uvas Dam across Uvas Creek. Before the dam was built, endangered steelhead trout spawned in Uvas Creek and migrated out to the bay to mature into adults.